Hello everyone, my name is Patrick Bounds, and today I want to talk to you about the Hubble telescope, something that I believe is the greatest experiment of all time. Now the first thing we want to ask is, why the Hubble? This is explained by the fact that we basically live in an ocean of air. Now, air is a fluid, just like water is a fluid, and I think most of us have probably laid down on our back in a pool and looked up, and we see that it's very, very blurry trying to look out of the pool. Well, it's the same way with air. We live under miles of air, and so when we try to look up and out of our atmosphere with telescopes, we see a big blurring effect, which scientists call seeing. Now, all this air causes the light to bounce around through it, and we can see the example of it over here on the right with the Hubble image on the right, which is much clearer and sharper than the ground-based telescope on the left, which is affected by all the seeing. Now, there's some ways that we can fix this. One of the ways is we can go up high. Essentially, we will limit the amount of air in between us and what we want to look at. So the higher up we go, the less atmosphere there is, and the better we can see. The other thing we can do is we can look at the sky on a clear night. We can essentially just look at it when there's not a lot of turbulence in the air, mixing the air up. There's not a lot of wind or clouds getting in our way, so that can help. We can stay away from cities, and this is good because cities put out pollution and make it very hard for us to see what we need to. The other thing, and this is what the Hubble does, we can just essentially go where there's no air. We'll get up and out and we'll orbit the Earth. So that's exactly what the Hubble did. But now, how did we get the Hubble? Well, in 1923, a German scientist suggested that we could do a big orbital telescope. But you see, this is rather hard, and they didn't have that in 1923, didn't have the technology. So it wasn't until 1969 that we actually see the approval given to NASA to actually build one of these telescopes. And it wasn't finally launched until 1990, costing $1.5 billion to build, and this is not including upkeep that had to come in the future and is still coming. But once we got this thing up there, disaster struck. And that's when we looked at the images, they were almost unusable. They were very, very blurry. We couldn't do anything about it. And this was because of a manufacturing defect on the main mirror. This had a flaw that was only 1/50th the thickness of a piece of paper. To put this in perspective for you, a piece of paper is 0.004 inches thick. And this was 1/50th of that, making this so blurry you could barely use them. And it took 3 years for us to actually get a rescue mission up there to fix this. So this does expose a flaw in the Hubble telescope, is that it's very hard for us to fix it if something goes wrong. But as you'll see in a second, even though the Hubble telescope is costly and it's hard to fix, it's still an amazing experimental instrument. And that's why we get to hear of why should you care about the Hubble? Why should you care about this big hunk of metal that's orbiting the Earth? And that's because the Hubble telescope is the most successfully experimental instrument ever. This has more papers written about its findings than any other instrument, and it's made 1.3 million observations. I don't think I've even done 1.3 million things in my life, and it's made 1.3 million observations. 3 of its biggest discoveries was that the universe is accelerating in its expansion. Now, before the Hubble telescope, we thought that the universe was accelerating at probably roughly a constant rate. And when the Hubble telescope was able to get up in space, get operational, and start taking distance measurements of things away from us and see how the lights redshifted and kind of track their rates of going away from us, we actually found that in its expansion, the universe is accelerating. And this actually won the Nobel Prize in Physics in 2011 because it let us age date the universe, something we couldn't do before because our telescopes weren't accurate enough. it actually discovered that there are supermassive black holes everywhere. Now, recently we were just able to take a picture of the event horizon of a black hole, but Hubble telescope's actually been taking pictures of black holes for a long time, just not that event horizon like what we recently saw. And what it found is that these supermassive black holes are at the center of almost every universe, and it appears as if they've almost even grown with the universe, which I think is pretty darn cool, and honestly just opens us up to so many more questions we could ask. The next thing it did is it really shed light on how stars are born. What we was able to do is go look at star-forming nebula, and it was able to see that this is actually a relatively violent process. There's intense radiation and shock fronts that clear out areas in the nebula, and so you just see this really kind of violent, crazy clearing that happens when these stars are formed, gas pillars and things, which you'll actually see in some of the pictures to come. Now, the big thing that I want to highlight is we have all these experimental accomplishments, and those are incredible. But the Hubble telescope also gives us things like these pictures right here, which I think are amazing, and I think this for a couple reasons. One, they're beautiful to look at. Absolutely. The next thing about them is they show us what is out there. They show us that there's more to us than just our solar system, than just our galaxy, that our universe is a beautiful place that we can't even fathom how incredible it's been made. And this has given us a glimpse into that. It's given us, for the layman like myself, it's given me a chance to see what is out there and really get perspective on how big our universe is, and get excited about science and what's happening, and the fact that we do have instruments out there that can take beautiful photos, like this one they call on the left is Mystic Mountain. This is one of those star-forming nebula that we've looked at to see the new star formation. Or this is on the right, a young stellar cluster that I think is only a few million years old, and it's just incredible to look at and think about all the things that have had to happen to bring these two objects into being. And we can see that with the Hubble telescope. A few more examples are this one on the left called the Eye of God, and then we have the Crab Nebula and the Ghost Nebula. So to kind of sum all this up, the Hubble is one of our greatest scientific experiments ever. It's been more successful than almost any other instrument, but at the same time it's done something that I think is almost equally important, in that it's let even the layman start to see that there are amazing things outside of what we have here on Earth. The Earth is an amazing thing in itself, but there are things so much larger and greater out there that we can see, and it's allowed even the layman like myself to really dig into this topic and see astronomy firsthand, that anybody in a public school who hears about astronomy can hop on NASA's website and see this and see what their teacher was telling them, and just really get a grasp for some of the amazing things that are out there. Here are all the references. I'm going to put these down in the video description so that you can go and look for yourself. The official Hubble telescope site with the gallery images, that's awesome. I've had a lot of fun just looking through and seeing all those while I was preparing this. And finally, I want to give you a few facts for nerds. The weight at launch of this thing was 24,000 pounds. It orbits at an altitude of 340 miles. This is a good bit farther than the International Space Station, and its orbit time is only 95 minutes. It's pretty incredible. It has a mirror diameter of 7 feet 10 inches and weighs 1,825 pounds. Now just think about this. We were talking about a defect messed this mirror up so bad, and it was only 1/50th the thickness of a piece of paper, over 7 feet and 10 inches. They say that this is so well polished, if you were to expand the diameter of this mirror to the size of Earth, you wouldn't find a bump larger than 6 inches. That's pretty incredible. As a mechanical engineer, I actually have some friends here at Charlotte that polish mirrors like this, and I can tell you right now, that is an incredible feat. Doing something like that over a small mirror is incredible, but they did this over 7 feet 10 inches. Finally, the pointing accuracy can focus with only a deviation of 7/1000ths of an arc second. So for those of you who don't know what an arc second is, If we take the 360 degrees in a circle and we divide that by 60, we now have 60 minutes. We then divide the 60 minutes that we just got by 60 to get arc seconds. This is about the equivalent as if we took a dime and we shot a laser pointer. We could put it on the dime's forehead from 200 miles away. That's pretty incredible. And finally, it transmits 150 gigabytes of data to Earth a week. It's shooting data through space at 150 gigabits a week. That's pretty darn incredible. So I thank y'all for watching this presentation. I have had a lot of fun doing it, and I really hope that this will inspire you to go explore the Hubble telescope and some of the amazing things that it's had to offer us. Have a good one.